Greetings everyone. This brings us to the last of the scheduled lectures in this course in statistical analysis and research methods. Up until now we have developed methodologically a step-by-step understanding of statistical methods as they are required to do systematic research. And we have moved from why we do research to topics such as how research enterprise is conducted, and then moving on to the statistical methods and starting from the very basics of descriptive statistics and then moving into more advanced topics such as probability distributions, testing hypotheses such as the mean difference test, that is the t-test, and some other tests in the process. We have now reached a stage where we can put all this into a coherent framework and work on the topic of regression models, and we now move from univariate analysis towards a multivariate framework. So today's lecture is regression models, and when we talk about regression models, the underlying theme is all else being equal. And our agenda for the day is as follows. We begin with the history of regression analysis, as to how this method became known and how it was discovered. And then I will spend some time explaining the concept of all else being equal and why it matters in statistical analysis, or why it matters in research in general. Then I will explain how research should be done in a step-by-step analysis. I have sort of a snake and ladder diagram that explains it. And then I also discuss what kind of questions can regression address, what kind of tools that it can replace as well. And then we talk about the various topics, explaining moving from regression being curve fitting to an example of weight and height, how weight could be modeled as a function of height, and then looking at housing prices and what can be learned from housing prices, how can we model them using regression analysis, and then lastly focusing on how households' consumption of food varies as a function of household size. But then if you want to understand it in a more multivariate framework, what is needed and how regression could be of assistance. So Francis Galton is credited with discovering regression model, and what happened is that while he was studying human beings and genetics, he discovered that, or he observed that often tall parents have tall offsprings. That is, children born to parents who are tall often end up being tall. And he also noticed that this increase in height does not increase or continue to increase in successive generations, so that one generation ends up being taller than the last one, and so on and so forth. Had that been the case, you would notice that the height of offsprings in successive generations continue to increase, and that could result in people being very tall. What he noticed, that is Sir Francis Galton, he noticed that there was a tendency which he called, there was a regression towards the mean tendency. That is, that yes, tall parents had tall offsprings, but that did not continue through successive generations. There was this tendency to move towards the mean. So what he did is he was studying this, and he was rather intrigued by it, and he consulted his uncle, and he said, I'm very interested in the problem, but but it's not really settling with me. And obviously, and of course, his uncle, was Charles Darwin, and Darwin suggested and encouraged him, Francis, to keep on probing, and then the result was this paper that he wrote, and it was called The Regression Towards Mediocrity in Hereditary Stature, that is the height, and it was published in 1886 in the journal Nature, and it's also available online, and I have made the URL available online if you are interested. This is the URL, and the one of the interesting quotes that I found was that from the paper, that the average regression of the offspring, and this is the average regression of the offspring, is a constant fraction of their respective mid-parental deviations. And so if the parents are each 2 inches taller than the averages for men and women, on average the child would be shorter than its parents by some factor. Obviously, it was a breakthrough study, not in terms of just genetics, but also in terms of the methods used to study this, and therefore the result was amazing. Since then, regression has been used in hundreds, if not hundreds of thousands of papers and studies that have been conducted, and it is now the regression as a tool is now considered as the workhorse of statistics, and from psychology to genetics to epidemiology to law to economics to education to any discipline that requires empirical research. Regression is there one way or another, helping resolve or solve questions. So what kind of questions can one put to a regression analysis? And I'm just presenting a small subset of questions. For instance, do tall parents have tall children? And so you can look at the height of parents and height of children, collect some data, and you can undertake regression analysis. Now, that would be a simple analysis, and then moving forward, you can ask questions: do women spend more on clothing than men? That is the spending on clothing is higher amongst women than it is among men? And then you say, well, it's not a complete question. You can throw in more information. Do unmarried women spend more on clothing than married women? Or do unmarried women spend more on clothing than men or married men? So obviously, the spending on clothing is not as yes or no question. When you compare it between men and women, it has multiple dimensions. Another dimension is for instance, do married women with children, for instance, spend less on clothing than women who do not have children? So now you realize that a simple thing such as spending on clothing is influenced by many other factors. Is a woman married or not? Are there kids, children there? Does a woman works or not? And so on and so forth. So when you're trying to figure out how much a woman spends on her clothing, you need to account for other factors that may impact her decision to spend or otherwise. Now here's another question: do households spend postpone buying expensive goods during recession? So recession is a time when the economic activity has slowed down, and there are layoffs, and people are losing jobs, and so in those times of economic uncertainty, do households postpone buying expensive goods such as cars, homes, and the like? But then the question is it applicable to all, or do we look at the income? So do low-income households postpone buying big ticket or expensive items, and like a refrigerator, for instance? Or do households living with young children postpone buying expensive goods during recession because they're afraid, they may be afraid that if they lose job, pay for the living expenses for their children, and therefore let's not spend money until we have some job security. So all these questions lead you to one interesting conclusion, that you can ask a question, but there's more than one variable or more than one factor that you have to account for in answering that question. And that's where all the previous methods and techniques that I have shown you in this course, such as TSAT, would not be a very big help because they can test for one factor, right? Married versus unmarried, but they cannot account for all these factors. For instance, what is the impact of spending by women on clothing in case a woman is married and has no children versus married with one child versus married with two children, so on and so forth. So you need a statistical technique that can account for multiple factors and control for them while you can focus on the variable or factor or a phenomenon of interest. So the use of regression could also be extended to questions of choices. For example, do more women eat cereal for breakfast than men? And then here's a choice, cereal versus non-cereal breakfast. Or do single or two-person households prefer living in a condominium or an apartment than households with children? And here the choice is between various types of housing. So you can have a regular detached or a semi-detached house versus an apartment or a condominium. And then the question is, those who are smaller households, such as singles or two-person households, are they more likely to live in an apartment than those with children? Or a question if do Canadian buyers prefer Japanese automobiles over American cars? So there's a choice between what national make of a vehicle would you buy? Or a question about if the couples are postponing child rearing to later years in their lives. For example, instead of having children in their 20s, are couples having children in 30s, and in some instances now in 40s? Or do, in an example from Canada, do urban voters in Canada vote Liberal more than they vote for Conservatives? And that is commonly observed here, that the urban Canadians vote Liberal more often than they vote for Conservative Party. So, and then in all these questions, when you account for other variables that are of interest, but then here the key variable of interest is urban. So how would you account for the geography of the voters and their income and their other influences? And when you control for all those, the variable of interest, the urban voters, so you look at the urban voters only, and then you decide if um, if it is true that urban voters in Canada vote Liberal for vote for Conservatives. With regression, one can move from partial answers towards more complete answers. And let me give you an example, or a series of examples. There exists a positive correlation between obesity, that is, people being overweight, and suburban living in North America. Now, this holds true for North America alone. Now, what does it mean? It means that people who live outside the main city and live in the remote parts of the suburbs of the city, which we call suburban or suburbs, there is a higher tendency that has been observed between people being overweight, that is obesity, and those who live in suburbs. There's also a positive correlation between fertility, that is higher rates of children, and suburban living. That is, families who live in suburbs have more children than those who live in the city center. Now, what does it mean? It means that if you plot a correlation between fertility rates and those who live in suburbs and versus city center, you would notice that those who live in the city center have lesser or fewer children. There's also a positive correlation between poverty and fertility rates. That is, if you look at the international scale, you would notice that poor countries have higher fertility rates than those that are richer or high income countries. Furthermore, there is a positive correlation between housing prices and proximity to subway stations. That is, the underground trains stations are called subways. So and there's those houses that are located closer to underground train stations or subway stations are often of higher value or higher prices than those that are located further away. So if you were to plot a correlation between housing prices and the location of subway stations, you will find a positive correlation. So um, what does it mean? Let's think about other factors that may also be instrumental. Now, it is also true that those who live in the suburbs have higher incomes and are older people. So two things matter here. When you get older, your metabolism slows down, and when you get older and you've been working for a longer period of time, you have higher income, but you also have children, and you're entering a stage in your life where the opportunity to exercise is not as widely available as when you are 20 something and you have freedom to do all that in terms of time and in terms of other pressing arrangements or demands on your own schedule. So could it be true that it's not suburbia, but it's a question of lifestyle or life cycle that determines who the impact on obesity rather than the just suburban or non-suburban living, that one has to look for age and income, and in reality is if one account for age and income and other instrumental factors and then have a variable called suburbia in the model or in the analysis, and if that variable or factor becomes influential even after you have control for the age and income and other important factors, then you have an answer. Well, with correlation alone, you cannot have that answer. You cannot control for these things in correlation analysis. Only regression allows you to do so. So as I mentioned earlier, a positive correlation exists between fertility and suburban living. But also, it is true that when you move to suburbs, the housing prices are lower, and therefore the young households who are about to start a family move to the cheaper housing locations to raise a family, and it's not the location of the suburbs that encourage people per se for higher fertility rates. It's just that housing prices are cheaper and households need more space to raise a family, and therefore younger households move out to the suburbs to raise families in search of cheaper housing. So if you're looking at the fertility rates and you want to know if um, other factors are influential other than just suburbs, then you need to run a regression model to control for that. Now, what about poverty and fertility rates? Well, yes, it is true that low-income countries have high fertility rates, but low-income countries also have high mortality rates, and there's something called the replacement effect. So what happens is that fearing that the children who are born in low-income countries may die of disease or some other reason, households produce more children to compensate for any future losses for their children, and that's the reason behind, to a large extent, behind higher number of kids in poor countries compared to those in high-income countries. So it's not poverty that leads to higher fertility rates, but instead it's the mortality that is also influential. And obviously mortality is a function of income. If you have high sufficient income, you can afford to pay for better healthcare and better living standards, and thence avoid in this trap of mortality or higher mortality. So basically, moving from partial answers to other influential factors, one can see that a simple question could have a complicated answer because there are multiple factors that are influencing the answer, and therefore you need an analytical mechanism that can account for other factors while you can explore further the variable of interest, such as suburban versus urban, such as low-income countries versus high-income countries, and so on and so forth. Now there's something else that is called Superious correlation, and a Superious correlation means that something else is responsible for the phenomena that you're observing. I'll give you an example. A positive correlation exists between ice cream sales and drownings. That is, people who die while swimming. And the question is, do ice cream sales cause drowning deaths? Well, let's look at this phenomena. You have ice cream sales, drownings here, and sales. And you get something like this. So you may think that ice cream is responsible for the deaths, but the reality is that ice cream sales go up during summer, and because you don't buy that much ice cream during winter months, especially if it's freezing cold out there. And also drownings, this is death due to being submerged in water. Drownings, they also go up during summer months because people go out swimming, more common during summer. So the correlation is in fact summer, or summer months. And what you see, the relationship between ice cream sales and drownings, that is a spurious correlation, because the real thing that you should be concerned with is this, that both drownings increase in summer, and so does the sales of ice cream, and there's no real relationship between the two, right? So that also is an important thing to consider before we jump on to regression. So when more than one factor is instrumental, what to do, right? Factors affecting spending on clothing by women was the example that I used earlier. Well, think about it. The age of the woman matters, right? If she's old or young, or how old. And then also what is instrumental is the income, types of career, or lack of it. Maybe she's a stay-at-home mom taking care of the children, and then marital status, married otherwise, and then if she's married, what is the spouse's income, and then also personal taste. Some people like to buy designer clothing, and they spend large sums on clothing. Others just simply buy clothing, whatever is matches their budget. Presence of children has probably a downward impact on clothing spending, because you have to spend money on children. And then cultural differences. Now, Chicoutimi is a rural part of Canada, and Montreal is a cosmopolitan city. Obviously, clothing is more expensive here than it is here, and the choices more are here in Montreal than a rural part of Canada, and therefore cultural difference would also impact spending on clothing. Perhaps climatic differences. If you live in Florida, it's not as cold as if you live in New York, and you need warmer clothes, which are more expensive than the clothing you need for Florida. And obviously, well, not so obviously, sometimes proximity to clothing retailers also have an impact. If you walk by every day from in front of a good clothing store, maybe you're tempted to buy. Then someone whose walk do not include walking through a mall or something like that. So when more than one factor or variable is instrumental, simple correlation would not do. You need a multivariate analytical model where you can account for more than one factor that is instrumental, more than one variable or phenomena that is instrumental, and that is regression model. Now, a key concept in regression model is called all else being. And the phenomena is how to isolate the impact of one particular factor or variable by holding other influences constant. That is, if all else that matters is held constant, how is that one particular factor influencing the behavior? For example, what is the impact of proximity to public transit? What is the impact of proximity to public transit, that is those subway stations that I mentioned earlier, on housing prices, if the size of the houses and the structural type, the quality of construction, and all neighborhood amenities and other influential factors are the same. Like if we control for everything else, can we then see that those homes located near the subway stations sell for more? And then all else being equal implies that holding all else constant, what is the impact of the price for being closer to subway station? Right, and that is the problem, or that we can answer using regression models, that if we can hold all else that matters to the price of a house held constant, what is the impact then, and I should say then, what is the impact then on price for being closer to the subway station? And that is what the regression model does. It allows you to control for other factors that matter, and then you look at the phenomena of interest, or the variable of interest, and say all else being equal, the price of a house closer to subway station is more expensive than say $10,000 or something like that.